Okay, as you know, we have four methods to solve the system of linear equations. Okay, the first one is Gauss method, the second one is Gauss-Jordan, then the third one is inverse matrix, and then the last one is Cramer's rule. Okay, so in this video I will explain on the inverse matrix and also Cramer's rule. Right, so if A is not equals to 0, okay, matrix A is not equals to 0 and AX equals to B represent the linear equations where A is an n by n matrix and B is an n by 1 matrix, then the solution for the system is given by this equation. Okay, X is equals to inverse A inverse times B matrix. Okay. So if you want to use inverse matrix, firstly you need to find the inverse matrix of A. Alright. Okay, example 9, solve the following system by using inverse matrix. Okay. So you have 1, 1, 1, 3, 4, 3, 3, 3, 4 equals to negative 1, 2, and 3. Okay. Then the matrix just now is 1, 1, 1, 3, 4, 3, 3, 3, 4, X, Y, and Z equals to matrix B is negative 1, 2, and 3. Okay, so by using inverse method, firstly you need to find the determinant of A. Okay, determinant of A, so let's say I choose the last column. Okay, for the last column, here is plus, minus, plus. Right, so the number is 3, so we have plus 3, and then you have 1, 1, 4, 3, and then minus 3, 1, 3, 1, 3, and then plus 4, 1, 1, 3, 4. Okay, so this equals to 3 minus 1 minus 3, 0, plus 4, 1. Okay, so this equals to 1. Okay, after you find the determinant, you need to find the adjoint A. Do you still remember how to find adjoint A? Adjoint A is for you to find the cofactor transform. Okay, and then we'll start with plus, minus, plus first. So plus, then you have 4, 3, 3, 4, and then minus 3, 3, 3, 4. Then here you have 3, 4, 3, 3. And then plus, minus, plus, minus, plus, minus. Okay, and then the third one is plus, minus, plus. Okay, transform. Don't forget this T. T is for transform. Right, so you will have 7, negative 3, negative 3, Okay, so after you calculate all this, then you will get this matrix transform. So how to transform your matrix? The row will be the column. Okay, so basically this is your adjoint A. Right? So A inverse is equals to 1 over determinant of A times adjoint A. So is equals to 1 over 1. Then the matrix is okay. So basically this is your A inverse. So to find X is equals to A inverse times B matrix. So X, Y, Z equals to what is your matrix B? Is negative 1, 2, and 3. Okay, and then you calculate as usual. Make sure you know how to multiply the matrix. Okay, you get negative 22, 3, and 4. Okay, so this is how to solve the system of linear equation by using inverse matrix. Okay, next is Cramer's rule. The last method is Cramer's rule. So given the system of linear equation Ax equals to B, where A is an n by n matrix, X and B are n by 1 matrix. If determinant of A is not equals to 0, then the solution to the system is given by this equation. Okay, meaning that if you want to find the value of x1, then you need to find the determinant of a1 over a. x2 is equals to determinant of a2 over determinant of a, and then up to n. If you have xn, then it is equals to determinant of an divided by determinant of a. Okay, where ai is the matrix found by replacing the ith column of a with b. Replacing the ith column of A with B. Okay, this is Cramer's rule. Alright, so we are using the same um, equation as in example 9. Alright, okay, so in example 9, we have found the determinant of A, right? So determinant of A is, okay, never mind. I'll write down the whole equation. We have 1, 1, 1. Okay, so just now we have calculated the determinant of A, right? So determinant of A is equals to 1. Okay, now we have to find A1, the determinant of A1. Okay, how to find the determinant of A1 is by replacing matrix B into the first column. So to find A2. You replace matrix B into the second column. To find A3, you replace matrix B into the third column. Okay? So matrix, we want to find determinant of A1. So okay, so this is matrix B, right? The one in black. And then 3, 4, 3. Okay, can you see this matrix, the difference? Okay, I replace matrix B into this first column. Okay. Okay, now you calculate, you get negative 7 minus 6 plus 9. Sorry, this is minus 9. So you will get negative 22 for A1. Okay, now we calculate for A2. For A2, you replace matrix B into the second column. So for matrix A, I'm using the first column. Okay, so this equals to 3. So for A3, alright, and then I'm using the same column, which is 1, the first column. So I have 4, 3. Okay, and then you calculate, you get okay. So now x is equals to A1 over A, y equals to A2 over A, and z equals to A3 over A. Okay, so x, determinant of A just now is 1, right? A1 is negative 22, divided by 1 is negative 22, y is equals to 3 divided by 1 is 3, and z equals to 4. So x, y, z is equals to negative 22, 3 and 4. So we have the same answer as